All right, now we have chapter 6, which is all about quadratic functions. And lesson 6.1 is all about graphing our quadratic functions. Now, opposed to quadratic functions, remember we've already learned about linear functions, which can be of the form y equals mx plus b. And in those cases, whenever we graph a linear function, remember it always makes a line, a straight line, hence the name linear, the line. Quadratic functions, on the other hand, they don't necessarily make a line. They always make this curve, which we would call a parabola. So linear functions, again, make that line. The quadratic functions make this curve. Now the standard form of a quadratic function, anytime we say standard form, we're looking for f of x, or remember you can consider that y. F of x or y equals ax squared plus bx plus c, where a, b, and c are all real numbers, and a does not equal 0. If a was 0, we wouldn't have this. We just have bx plus c. Well, that looks way too similar to mx plus b. So if a was 0, it would just be a linear function. So that's why a cannot be 0, so that we still have the x squared. Basically, anytime that you have an x squared term, that's what makes a function quadratic. So tricks to know from standard form. Anytime that we are given an equation that we can put into this form, the y-intercept, like in this one, remember y-intercept is wherever it hits the y-axis. In this case, be right here. The y-intercept is going to be the point 0, c. So whatever this c is right here, that's what you would put into this side here, the y value of that coordinate, that's going to be your y-intercept. Also, this a that we have out in front here, if that a is positive, I want to write this in there, if a is positive, then it opens up like this one does. If a were not positive then, if a were negative, then it opened down. It would look something like this. This is a parabola. This case would be where a is negative. The x-coordinate of the vertex, so this spot here, the very corner where it looks like everything is stemming from, that's called the vertex. And the x-coordinate of that vertex is going to be negative b over 2a. So when we're given b and we're given a, we know that negative b over 2a gives us the x-coordinate, so the sideways plot of that vertex. To find the y-coordinate, we'd have to plug in our x-coordinate back into the function to find what the y-coordinate is. So moving on from there, every quadratic function stems off of its parent function, which is just simply f of x, or again y, equals x squared. And how you want to graph these is, one of the first things to do is just make a table. So if we use points like -2, -1, 0, 1, and 2, we just plug our values back into our equation. So -2 squared, which we got from here, would be 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So we can plot points like this. So we'd say -2, 1, 2, 3, 4. -1 goes with 1. 0, 0. 1, 1, 2, and 1, 2, 3, 4. So looks like our parabola stemming off like that. So with this, what we have here is our basic parent function. All other parabolas are going to look similar to this, and in fact just be kind of twisted or shaped according to this. Again, that vertex, the point where it stems from, in the parent function, our vertex is 0, 0. So that was our things to be wary of, to be aware of. If we wanted to graph a parabola or a quadratic function that was not the parent function, again, where we'd start is just start plotting some points on our table. And I always like to start with these ones, especially on these smaller, easier graphs. I'll show you later where you want to pick points to create for your table, but for now we'll use these smaller, easier ones because they center around 0. So in this case, we would just plug these points right in. So we'd have negative 2 squared plus 2 times negative 2 plus 1. So I just took our equation and plugged in our first point here. Negative 2 squared is 4, plus negative 2 times 2 is negative 4, plus 1. Negative 4 and 4 cancel each other out, so we're left with just 1. Trying our other point here, we would plug in negative 1 and say negative 1 squared plus 2 times negative 1 plus 1. Negative 1 squared is 1. 2 times negative 1 would be plus a negative 2 and plus 1. Well, 1 and 1 is 2. Minus 2 equals 0. Okay, we're going to want to try that for all of our points. 0 squared plus 2 times 0 plus 1. 0 squared is 0. 2 times 0 is 0 plus 1. And if we try that for positive 1, 1 squared plus 2 times 1 plus 1. 1 squared is 1. 2 times 1 is 1 plus 1. Looks like that gives us a 4. Get rid of this. I'll do our last one here. 2 squared plus 2 times 2 plus 1. 2 squared is 4. 2 times 2 is 4 plus 1 equals 9. Now here it looks like everything is centering around this point here. So we'll do one more further away. So from here we had a negative 1, negative 2. Let's do negative 3, just to be sure we have some good points to use for our graph. So we'd say negative 3 squared plus 2 times negative 3 plus 1. Negative 3 squared is 9, plus 2 times negative 3 is negative 6, plus 1. Well, 9 and 1 is 10, and 10 minus 6 is 4. So this will give us a 4. So we've got some points to use here. We have our negative 3. It goes up 1, 2, 3, 4. We have negative 1, 2, which goes to 1. We have our negative 1, which goes to 0. Our 0, which goes to 1. 1, which goes to 4. And our 2, 1, 2, goes all the way up to 9, which looks like it would be about there. So this would be our parabola, which looks very similar to our other one, our parent one, only with shift. Remember, our parent function is going to look closer to this, but it was just shifted a little bit over to the left to get our function in this case, which is our black parabola over there. Now again, looking at where our vertex is, looks like that spot is going to be at negative 1, 0. And our y-intercept, where it crosses here, we can see that that is at 0, 1, which fits with our trick from before. We just say plug in the c value into this spot, and that fits. So that's how we would be graphing that parabola.